This is David Stockberger, and what we're going to do, the example assignment, that is the example test 2. And first of all, we're going to get our data, and I'm logged on as example student. Before I begin, I want to show that I've loaded a number of things on my desktop to prepare for the test. One, I've got my calculator, I've got Excel, I've got Firefox, which has my probability calculator, and I've got SPSS. Step 1, we're going to take this data and we're going to put it into SPSS, and I'm doing it by using the mouse and holding down the left mouse button. Now I do the right mouse button and I copy it. The next step is I want to paste this into Notepad, and I'm just going to paste. So this is my data, and because SPSS doesn't like spaces in its variable names, I'm going to make diversity status one word and test score one word, and I'm going to save this file as a text file, and I think I will save it on my desktop, and I'm going to call it example test 2. It's viewing the notepad, so I'm just going to X out of that. Now I'm going to go to SPSS, and I'm going to read text data. And I'm going to look on my desktop, an example test 2, that's what I called it. I'm going to open that data file. I've got 6 steps to import the data file. Doesn't match a predefined format. It does have my variable names at the top. It is delimited. It's delimited with a space. Each line represents a case. We want all of the cases. The space is the delimiter. Looks like we're good. And we're just going to accept everything and finish. And our data file. We're going to look and make sure that our data file matches our actual data. Subject 1, 0, 205, 2.61, 5, and 40. And we'll look at subject 20. So we've got 20, 0, 577, 3.10, 6, and 87. Looks good. Our variable view looks good. They're all numeric. We might want to change the interview to a scale. And what we'll do is we'll just save this on our desktop, and we'll call it example test 2. It'll be a save file. Just in case something happens, it will be able to recall our data. Okay, the next thing we want to do is we want to create this composite variable, which is a combination of test score, GPA, and interview. And we want the test score to be weighted 3 times the interview, the GPA to be weighted 2 times the interview, and of course the interview. Now we just can't multiply because the test score would give us a huge number. So the first thing we have to do is we have to convert all of these to z-scores. And that's easy enough to do. We go to Analyze, Descriptive Statistics, Descriptives, and we don't really need subject, nor diversity status, but test score, GPA, interview, and we'll throw success in there just for the heck of it. Now the thing of it is we want to save the standardized variables, or standardized values as variables. This will create 4 new variables. It'll be the z-score of these. And we'll just click OK. So what we find is if we look at our output, we've got the mean standard deviation of our 4 variables. If we look at our data file now is considerably bigger because we have added 4 new variables, which are the z-scores for each one of these. So now we can create our composite. And to do that, we'll go to Transform, Compute Variable. Hold this over here. Composite. And the numeric expression, now we're going to use the z-scores. We use the interview plus, and we'll put parentheses in just to, and 2, we want 2 times the GPA. Click that up there. We'll add another plus. Yeah, put this in there just to make sure. 3 times the test score. So we standardized each of the 3 variables, and now we're going to weight the standardized values. And we just click OK. And we've created a new variable called composite. And we want to look at that in a little bit more detail. We'll add a couple more decimals to it, just so we can see it. So we've added some decimals to the composite. And it goes from what? -9 to 5 something, or 6 something. There's one that's almost 7. Okay, so this is our data. This is the raw data we're going to look for. Now we can start doing our test. And before we do that, looks like we're going to need some correlations. And before we do anything else, we'll save our data file. And we'll do analyze. We want to do all the correlations. We'll look at bivariate correlations. And we'll throw in diversity, test score, GPA, interview, success. We'll throw in the composite. We'll just throw in z-score for z-score success, just for the heck of it. Pearson looks good. We'll just take all the standard options to defaults, and voila, our correlation matrix. Okay, the variable that best predicted success, and we've got a choice of 4. We'll take our data file and move it out of the way for a minute. The variable that best predicted success looks like it was test score and GPA come really high, but the composite is a little bit higher than all of them. So the composite being 0.776, test score 0.760. We don't really gain much using the composite over the test score, but we gain enough to make the composite the right answer. So we'll answer 4 for the first item. The correlation between test and GPA. Okay, test score and GPA looks like 0.672. correlation between diversity and test. Diversity and test, diversity status and test score, minus 1.89. Whoops, I'm going to put a minus sign in there. The relationship between diversity and test can be described as, because it's negative, and because diversity, if we look at diversity, 1 was a diverse candidate, 0 was not. So the higher diversity, the lower the test. So we can say diverse applicants did worse. So we'll put a 2 in there. The z-score for test, for applicant 7 for test, it shouldn't be too hard to find. Now we had to put subject in there because this would be applicant 7, and when we start to sort these things, we need to have applicant 7 still here. For z-score for test for applicant 7 was 0.458. For GPA, applicant 7 for GPA, 0.569. Interview, looks like some easy points here. Interview was 0.470. The composite for 7 was 2. Make sure you got number 7. 2.98. The correlation between composite and success. Okay, back here. Okay, composite and success. We already saw that was 7.66 or 0.766. The slope of the regression line, predicting success from composite. All right, so now we're going to have to go back to our data. We're going to have to compute the regression line. We're going to predict success from composite, analyze a regression, linear. We're going to predict success from composite. And because we know we're going to need some things, we're going to ask for to save some variables. Let's save the unstandardized predicted variables and the unstandardized residuals. And continue, and we'll just go OK. I'm just accepting most of the defaults. The R is 0.766. We knew that. Okay. The slope of the regression line, predicting success from composite. We're going to go down here to the coefficients, and we're going to look at the unstandardized coefficient, 2.822. The intercept looks like it would be 68.8. Okay, the standard error of estimate. To pull this data up again. Standard error of estimate looks like it's 11.783. We'll just put 11.78. The predicted success for applicant 7 was, okay, pull up our data file again, and because we saved our predicted values in our residuals, that 77.21. We just looked at our data. If an applicant had a composite score of 1.78, the applicant's predicted success would be, okay. So here we're going to have to use the calculator to do this. And we'll pull up our calculator. And we know that our regression, we'll pull up our SPSS output just so we can see it. It's going to be A plus BX, so the composite. So if had a composite score of 1.78, we're going to multiply B times 1.78. So we'll go B, which is 2.822 times 1.78, which would be our X, equals, and then we'll add our constant to it, which would be plus 68.8. And we get 73.82. Okay, the lower limit of a 95% confidence interval. Okay, so this is our predicted value. Now let's go to our probability calculator. And basically, we're going to find a confidence interval where mu is the predicted score, in this case of 1.78, which would be 73.82. And sigma would be the standard error of estimate, which is 11.78. And we want a 95% confidence interval. And we get, as a low score would be 50.732. I'll just go 50.73. And the high score would be 96.91. All right, the correlation between predicted success and composite. All right, we did that, I believe. We'll go back to bivariate, and we will add to our variables, we'll add predicted success. And click OK. And our new data looks like unstandardized predicted value and composite. So we find the correlation between our unstandardized, the composite score and the unstandardized predicted value is 1, which makes sense because our unstandardized predicted value is a linear transformation of X, that is, of our composite. So we get a 1. The correlation between predicted success and interview. So here's predicted success in interview 0.347. Compute the predicted success of a new applicant with a test of 500, GPA of 3, and interview of 5. Okay, well this one's going to be a little bit more difficult. And here's where I'm going to use Excel. I could just use my calculator, but we'll go in with Excel. And we'll put X, and this would be the mean, and we'll put standard deviation, and make this our z-score. So our new applicants, the mean, going back to our data here, back to our original data. I made this problem pretty hard. So the mean of the test is 420.8. And the standard deviation is 149.11. Yeah, make these a little bit bigger so we can see them. Okay, and the score that we're looking for is 500. For the next one, which would be the, I'll tell you what we'll do. So this is the test. This is the GPA. This one's the interview. And this will be the composite. All right, so in our example, so we don't need this anymore, the mean for the GPA is 3.232. Mean for GPA is 3.232. Standard deviation is 0.3655. And the interview is 6 as mean, and the standard deviation is 2.128. Yeah, now we don't need these anymore. Put these back over in the other place. And the GPA was 3. And the interview was 5. Okay, so now we've got to compute the z-score for each one. All we're doing is finding the composite for this particular individual. All right, so the z-score, we'll do a computation here, is going to be equal to x minus the mean divided by the standard deviation. All right, so those are our 3 z-scores. So we've converted these x scores into z-scores. Now we've got to find a composite. Equals what, 3. We'll go back and do 3 times the z-score for the test plus 2 times the z-score for the GPA plus the interview z-score. Okay, so it looks like our individual that has the test score of 500, GPA of 3, and interview of 5 has a composite of minus 0.144 or 145. So now we've got to convert that to a predicted success, and we know that, we'll just put that down here. And that's going to be, going back up here, 68.8. All right, so this is equals 68.8, going back over here, plus 2.822 times, and our composite score, and we get 68.39. A lot of work. For that particular value. Okay, given that you set a cutoff score at the 50th percentile, you want to accept about half the applicants. Would you accept this applicant? All right. Let's sort by predicted success. Our individual has a predicted success of 68.39, and we would want a predicted success of about 71. So we're going to say no. We're going to say we would not accept that individual. What is the percentile rank of applicant 7 on predicted success? And find applicant 7 here. Way down here. And predicted success, we just sorted by predicted success, and it looks like they're going to be 15 below, and 1 at his score of 77.21. So we would have 15 divided by 20, which would be 3/4, or 75, plus 1/2 of 1/20th, or 1/40th, which would be 0.025. So we would have 75 plus 77.5. So we'll say 77.5 as the percentile rank of applicant 7. What percentage of the non-diversity applicants would be accepted if you set the cutoff at the 50th percentile? Okay. Back to our data file. And we're setting the cutoff here between 10 and 11. So we would accept, so we have of the we have 1, 2, 3, 4 diversity candidates, and we have, that would make 16 non-diversity, and of the 16, we would, what would be, okay, of the non-diversity, we have 1, 2, 3, 4, 5, 6, 7, 8. With 8 out of the 16 we would accept, and we would accept 50%. What percentage of the diversity candidates? Well, there were only 4, and we accepted 2 of them. We accepted 2 of them, so we would say 50% of the diversity candidates would be accepted. which applicant was the composite the most accurate? All right, we're going to look at residuals, and we're going to just sort those. And the most accurate would be the smallest residual, and that would be, it would take the absolute value, and it looks like applicant 14. Was the least accurate in predicting. We'll go back to our data, and the largest absolute value looks like subject 13. Which applicant had the highest predicted success? Okay, going back here, we'll just sort these again. It looks like applicant number 3. Did the applicant with the highest predicted success have the highest success? Okay, we can find that out. And okay, the actual success, well, no. The applicant with the highest predicted success had kind of low success. There's 96. So it looks like there are a couple 96s in there. Did not, so we say no. What is the normal percentile rank of success for applicant 7? All right, so we'll go back to our probability calculator. And now we're going to look at area below and looking at success for applicant 7. So the mean, I can pull up our data over here, go back, look at our data. So the mean for success was 68.8. Sigma was 17.834. And our score for applicant 7 on success, okay, what was that? Applicant 7 score on success was 93. Okay, so we'll put a 93 in there. Is the actual score. And going this way, looks like the normal percentile rank would be 91.3. What is the normal percentile rank for predicted success? Okay, back to our calculator. Predicted success. I don't think we have that variable. All right, so analyze, descriptive statistics, descriptives. We'll add unstandardized predicted success to there. Okay. So 68.8 was our mean, 13.658 was our standard deviation, our estimate of sigma, and the score for predicted success for applicant number 7. What do you say it was here? 77.21. and we get 73.1. Is there another set of weights that might give a better estimate of success? Well, we don't know, but I would say yes. In fact, this question is a preview of when we get into multiple regression, when we're actually going to find optimal weights for these guys. Okay, so we've got all 30 in there. Now for the big test, we submit our assignment and see what score we get. 29, we missed one. Oh, correlation between diversity and test was not minus 1.89, but minus 1.89. Darn. Well, 29 out of 30 isn't bad. And that was just a kind of a lapse of memory that we missed that one. And that is how you do test 2. Now I'm ready to start the real test. I would click on Start the Real Test. The only difference is now I've got 30 numbers and I start the whole procedure over. Good luck.